Let us start with association, also known as a user relationship. Association is a loose relationship between two objects where one object either knows about or uses another object. Think of it as a connection, but not a deep or permanent one. It's different from inheritance or composition. Here, the objects interact, but they don't really belong to each other in a strict way, unlike inheritance or composition. If you look at the highlighted text in the slide, it says loose relationship between two objects where one object knows about or uses another. And notice the word loose here, that is the highlight. That's very important to, keep in mind. Let's look at the first example on the left. We have a teacher and a classroom object. A teacher can use a classroom or know about multiple classrooms, but the classroom themselves don't specifically belong to a teacher. This is a classic example of association. The teacher and classroom objects interact, but they aren't tightly bound together. Next, in the middle, we have an author and book. An author can write multiple books, and each book knows about its author. But again, there is no ownership here. The author doesn't contain books, and the books doesn't contain author, which means that there is no lifetime dependency between the author object and book object. They simply know about each other and use each other's information. On the right side, we see a library and its members. Library uses or associates with its member, and member also use library. But there is no strong or permanent bond. They don't contain each other. There is no lifetime dependency between a library object and a member object. If a member leaves, the library still exists. So, to summarize, association is all about one object using or knowing another object without a strong dependency or ownership. It's the most basic and flexible way for objects to interact in object oriented design. Let's look at this with an example. Let's take a look at a practical example of association in C Sharp using the relationship between author and a book. First, we have an author class. It has a property name and a method writeBook, which takes a book object as a parameter and prints out message saying the author is writing a specific book. Next up, we have a book class with two properties, title and book author, which is an object of type author. Notice that book knows about its author. This is association. Now let's see how we use these classes in the main method. First, we create an author object and set its name. And then we create a book object and set its title. At this point, the book doesn't have an author associated with it yet. To establish the association, we set the book author property of the book to the author object that we created earlier. This is what forms the association or user relationship. The book knows about its author now. We use this association in action. First, the author writes the book by calling author.writeBook, and then book displays the author by calling book.displayAuthor. And when we run this, we get to see the desired output. Now, the next form of object relationship is aggregation. Aggregation represents a has-a relationship between two classes. It is a weaker form of association where one class can exist independently of the other. That means just because one class uses another, it doesn't control its life cycle. Let's take the first half of the slide. On the left, you see a university and multiple students. In this scenario, the university has students, but students can exist even if the university shuts down, right? Students are not tightly bound to one university. They could transfer, drop out, or graduate. So the university class has a collection of student objects, but it does not own them. That's aggregation. Now let's look at the right side of the image, a library and books. The library contains books, but books can exist even if the library is closed. A book is not destroyed when the library object is destroyed. It can be moved elsewhere. This is another aggregation example. The library aggregates books but doesn't own them in the sense of object life cycle. Now let's look at the code to understand this better. Let's start with the student class. This is a simple class with a name property initialized via the constructor. It represents an independent entity, a student. And then we have a university class which has a university name and list of students that holds multiple students. Notice here, we are not creating student objects inside the university. We are simply holding reference to student objects created elsewhere. That's the key aspect of aggregation. In the main method, we create two student objects, Alice and Bob. Then we create a university named Oxford and add both the students to it using the add student public method. The important point here is, even if we remove the university object from the memory, the student objects S1 and S2 still will exist independently. That's what makes this an example for aggregation. Think of it this way: a student may enroll in a university, but the student's identity doesn't vanish if the university closes. Aggregation means the part can outlive the whole. To summarize, aggregation defines a has-a relationship. The life of the part is not dependent on the whole. Objects are passed, like how we pass the object here S1 and S2. Objects are passed and referenced and not owned and contained. Now let's look at the third type of object relationship, composition. It is an object relationship where one class contains the object of another class. It is a tightly bound relationship where the child class has an object lifetime dependency on the parent. Let's use a simple analogy. Imagine you're building a car. Every car has an engine. The engine can't exist independently. Once it's a part of the car, if the car is destroyed, the engine inside it is also gone. This tightly bound relationship is what is called composition. Let's look at this with an example. Here we have a simple engine class with a method called start. It just prints out a message when the engine is started. Now let's look at the car class. Inside it, we declare a private field of type engine. In the constructor of the class, we create a new instance of the engine class. I repeat, we create a new instance of the engine class. This means that the car owns the engine's lifetime, the object lifetime, is tightly coupled with the car. In the main method, we create a car object and call the start. This internally starts the engine first and then prints the car is running. This is composition at work. The car class contains or owns or is composed of an engine, and it controls the engine's behavior by calling its method. Thank you for watching our video. Do subscribe our channel for more such videos, and thank you for your support.